Welcome to Virtual Process Control Laboratory. I am Professor Uttam. Today I will discuss about temperature control system. Initially, we will see how difficult it is to control temperature manually. So this is a tank and is a mixer motor operated to have a uniform temperature after the liquid is entered. So initially some liquid is entered and we try to control the level of this liquid with the help of this exit drain valve by anti-clockwise opening. So you can also adjust the inlet valve so that level will come down. Say let it be 50%. So manually we can manage this 50% with great difficulty because there are two valves, one at the top and another at the bottom. If the tank is large and it generally metallic tank, you cannot see the level also. You have to use certain deep tape or deep rod or gauge glass to see the level, and then you can also have a temperature of the inlet water, say liquid water here. It may be any liquid. So this temperature will be the same as the liquid of this tank. In the its temperature is also being shown here in the exit liquid out. And now if you switch it on, then this temperature will rise as heater is on, and the system is so designed that it has to be brought down below 100. So we put it off and then again on. So if you want to maintain temperature, you have to go on doing this. It is a difficult job also, and switches may be damaged. So we'll go for a automatic control system. Here you can see its inlet temperature and the exit temperature and the level to be measured and the valves to be operated manually. It is quite difficult job for a single operator. So we'll go for automatic plant. So we'll place this as an automatic plant. Here you can see this. There is a controller, level controller, temperature controller. A level controller controls the level, which gets this level transducer signal, and thermocouple is the temperature signal which enters the temperature controller, which are connected. So if you press auto, it will be automatic. So before that we must fill the tank. So we enter the tank and also full open the exit valve, and then you set the level in this tank, say at 50%, say it is 50%, and temperature, say you want to make it as say 80 degrees centigrade. And then press auto. You will see the action here. This control valve under this level controller manipulates the flow such that level is 50%, and the temperature is being adjusted by variable resistance. This is as if it is a jockey which moves up and down to vary the resistance for the heater, so the heating rate will be different. So we'll see the temperature is rising, and it is trying to reach 80 degrees centigrade, and we can see also the recorder for recorder. So we can display the level first. You can see level is almost reached, it is 50%, and display temperature. So temperature is also reached 80 degrees centigrade, and now if you want to make it, it is slightly plus minus 80, and if you want to make it as 50 or 60 degrees centigrade, you will find that this level is maintained 50 and it is taking time. The temperature will not fall so fast like level. And see that the jockey position is still here, giving minimum resistance, so that heating rate is high. It will take certain time. So now resistance has been increased and heating rate has been reduced, and it's coming down to 60 degrees centigrade very fast. And now if you go to the recorder, you can see the record display both level first. So you see that level. So level has already reached 50%, and display temperature. Temperature is trying to reach this 60 degrees centigrade if you go on pressing it, or you can see that this is also trying this plus minus 60. So you can see the recorder display the temperature. So it is reaching this 60 centigrade with a small amount of fluctuation. So you can see that both temperature and level are controlled by a controller having both level controller and temperature controller. You can also have tuning parameters. It's a direct acting for temperature, and for this is for level is reverse acting. That is understood heuristically, that whether it is reverse or direct. You know that reverse means increase decrease, decrease increase. That is for level, and is a proportional band. Bias value is given, reset is 0, rate is 0, so it is simply proportional control. And here you will see bias is 12, proportional band is given, reset time is 1, rate is 1, it's a PID control, and both the controllers have addresses. This has address 1 and this is address 2. So it has reached 60, now you can make it 70 also, and then we will see the graph. So display level I think is 50, it is unchanged. This 50%, and display temperature. So temperature already rose above 70 and then coming close to 70. There is slight fluctuation. So it is going to be 70 soon. You can see that it is 70 plus minus 1, and also you can change the level, say 60%. It is already reached 60%, and if you want to see the recorder again, you can see the display level. So level is 60%. If you press it once again, you will get the current value. This is from 50 to 60 it has risen. So here it is 60, exactly matching with the PV value. A red one is PV value, the measured value, and blue one is your set point. And display the temperature. See, it is 70 degrees centigrade, it's matching and there is no offset. So you can see that both the level and temperature is maintained. I hope you understood the mechanism of control system. Here this exit temperature is also showing 70 and inlet temperature is 0 degrees centigrade here. So whatever it is, you can change this temperature and can restart the system and control both the controllers will take action. I hope you understood this control system. Thank you very much for watching this video.